Hello guys and welcome to the last video of Kinematics MCQs. So this time we are going to be going over the tier 3 MCQs, so the most difficult ones. And I hope that some of you look at this and say that this should have been in the tier 2 MCQ, because I know a lot of you geniuses out there are going to be better students than I ever was. So it might be a difference of opinion. Obviously the MCQs that I have handpicked, they are according to my opinion, and yours might be a bit different. So for example, you might think that an MCQ that is here should have been in tier 2 and one from there should have been here. So again, this is just my judgment. So let's get started, and this one is from March 22 paper 12. So let's have a look at this one. So March 22 paper 12. A sprinter takes a time of 11 seconds to run a 100-meter race. She first accelerates uniformly from rest, reaching a speed of 10 meters per second. She then runs at a constant speed of 10 until the finish line. What is the uniform acceleration of the sprinter for the first part of the race? So for the first part of the race, what is happening is she is just accelerating uniformly. So her initial speed is 0, because this part says she accelerates uniformly from rest. So this means that she was initially at 0 speed. The final speed is 10. The time is 11 seconds. But keep in mind, this 100 meter is not just covered in the first stage. It takes the culmination of the distance of the distance she ran in the first stage as well as in the second stage, because until the finish line, so the 100 meters is covered in both the first part and the second part. We were only asked the uniform acceleration of the sprinter for the first part. So just a heads up in case you were thinking of this, so we can't use S. So thinking of the equations of motion, we have U, we have V, we have T, and we need to find A. So we can simply use the first one, which is V equals U plus AT. So V is 10, U is 0, A is what we need to find, and time is 11. So this turns out to be 10 upon 11, which is 0.91. So I think I agree, this should have been in the tier 2 or tier 1 MCQs even. This isn't really all that hard compared to the ones we've done in the previous video. Let's go ahead. So let's have a look at this question. Now this one is from summer 21 paper 13. Kind of a different question. So have a look at it while I'm writing the reference. So this is summer 21 paper 13. So a steel ball is dropped from rest from a height h above the ground. The ball hits the ground after a time t. This is repeated for a number of different heights. The graph shows the variation of h with t square for the ball. So we have height in h, and we know the time is t. So the ball hits the ground after a times t. So this time t is not on the x-axis, but instead we have the square of t, so t squared on the x-axis, and we are getting this graph. So a straight line graph between h and t square implies that h is proportional to t square. So the first hint I get from this is I need to find an equation that relates h and t, but the t should be t squared. So if I think about my equations of motion, so let's first write all of them down. So this is V equals U plus AT, which is the first one. The second one is S equals UT plus half AT square. And the third one is V square equals U square plus 2AS. And how many of these do I find T square? That's right, only in the second one. So I need to think about how I can use this equation in this scenario. So basically the height from which a steel ball is dropped from rest from a height h, so this is going to be the displacement or the distance covered by the falling ball, right? Again, it is dropped from rest, so this means that the initial speed, so let's use a different ink for this. So since u is 0, so this entire term becomes 0. So we have this equation now. So basically S equals half a t squared. So we are shown the graph of h versus t squared. So this entire thing here, so all of this is basically the gradient of this line. So the gradient of the graph is g, which expression gives the acceleration of the ball. So that should be equal to, so the acceleration here is just equal to the acceleration due to gravity, because this is a falling object. So a is just equal to g. So the answer should then be g upon 2, which corresponds to option A. So let's do a couple more of these questions and then wrap this unit up. So this question now is from Winter 20, paper 13. So an object moves in a straight line. The graph shows the variation with time t of the velocity v of the object. So what we have here is a velocity time graph with velocity on the y-axis and time on the x-axis. What makes this question different from the ones we've seen is that velocity is also negative here, right? At time t equals to 0, the object is at point x. So this is where it started from. What is the displacement of the object from point x at time t equals 0.8 seconds? So what is being asked here is this, that what is the displacement at this time? So I could probably do better than that. So this is what is being asked. So we know that the area under the velocity time graph corresponds to displacement. But the problem is that unlike a speed time graph, velocity is a vector, right? So, and the hint that is given, the hint to that is given by this area right here. So this area is under the x-axis. Sorry. So this area here is under the x-axis. So this means that this displacement is negative, right? So this is negative displacement. Because the velocity is negative, so this means that if we calculate this area first, so that would be an area of a triangle. So half into 0.2 into minus 2. So this turns out to be minus 0.2 meters. So I can think of this distance as being covered from the time 0 to 0.2. So from here to here, it was like behind the origin, and it's traveling and it's coming to its reference point, the origin. So after this time, then it's going, the velocity is increasing throughout. So then it's covering some positive displacement here, right? So this is then equal to, so let's shade this region again. So this region is what we need to find. So this area would be, so again, area of a triangle. So half. Now I need this length, so 0.2 till 0.8 is 0.6. And the height is from 0 till 6. So this is 6. So 0.6 times 3, that is 1.8 meters. So from here to here, it covered a displacement of negative 0.2 meters. From here to here, it covered a positive displacement of 1.8 meters. So if I think about displacement, then that is the sum of both of these, right? So minus 0.2 plus 1.8, so that becomes 1.6 meters. If it was a simple distance time graph, then this graph would never have been below the x-axis. But since it's a velocity time graph and the area under the velocity time graph is displacement, so we need to take care of these things. Let's move on to another question. So this one is from Winter 21, paper 1-1. So question number 6 of that paper. So an archer shoots an arrow at a target. The diagram shows the path of the arrow. So this line should give you a pretty good idea of what type of motion this is. So basically this is projectile motion, right? Air resistance is negligible. The graphs show how three quantities P, Q and R vary with time. So P is a constant throughout, Q is increasing by the same amount each second, and R has a different kind of so R has a different kind of a graph. So it doesn't increase uniformly. It reaches some maximum value and then it starts decreasing again. The question asks which quantity could be the horizontal component of displacement and which quantity could be the vertical displacement, the vertical component of the displacement of the arrow. So we know that, let's say this is the angle V, this is alpha. So we know this can be broken down into its vertical component. Let's call that Vy, which would be V sine alpha, and the horizontal component would be V cos alpha. And last time out we also saw that if we see their variation with time, so the horizontal component always remains fixed as V cos alpha, but the vertical component actually experiences an acceleration. So if I think about the components, let's draw this here. This would be V cos alpha, this one would be V sine alpha. So it experiences a deceleration of sorts by the acceleration due to gravity. So that would be equal to V sine alpha minus gt, right? So let's think about this in terms of displacements, right? So the horizontal displacement is fixed, which is V cos alpha. The horizontal velocity is fixed, which is V cos alpha. So this means that if your velocity is fixed, so it is increasing by a constant amount every second, right? So the horizontal displacement would then be increasing by a constant amount every second, which corresponds to option Q. Another way you can think of this problem is that if the horizontal component is fixed, then this means that the displacement time graph should be an upward sloping straight line, because the gradient of the displacement time graph is velocity, right? So this corresponds to Q. So the horizontal component of displacement is definitely Q, and hence we have option B as the correct answer. But still, let's go ahead and understand why V sine alpha minus gt, which is the vertical component, is R. So first off, it is covering some displacement, but as the deceleration starts to kick in, the vertical displacement decreases, and it becomes constant at the maximum height. And after that, the displacement starts to decrease, so it goes up until it reaches the maximum height, and then it starts to decrease again, and the vertical displacement becomes 0 again, assuming both of these are on the same horizontal ground. So this so vertically, if you think about this point and this point, so there is no height difference between them, so there was never any displacement in the vertical direction. So this is why the graph of the vertical one should have corresponded to R. So this is the vertical one and this is the horizontal one. Hence option B is the correct answer for this one. Let's go on to the last question. Oof, even I'm getting tired of these questions, but hang in there, we're almost done. So this is winter 21 paper 13. Again, a question related to graphs. So the graph shows the variation with time of the acceleration of a car. What must the shaded area under the graph represent? So this is an acceleration time graph, so area corresponds to velocity, right? So if you think about it, acceleration is the rate of change of velocity, right? So if I write it in the terms of in the form of a formula. So this is what it means. So if I multiply acceleration in time, right? So this is a particular value of time. Let's call this t. So a times t then gives me the change in velocity of the car, right? So this is not the average velocity, this is the change in velocity, because let's suppose this, and let's take a number just to aid our understanding. So let's say this value is 2. So this means that the acceleration is a constant 2 meter per second squared. So the speed is increasing by 2 meter per second every second. So I don't know what I started off with. All I know is my acceleration is increasing by 2 meter per second every second. So if I add all these slices up, so I'm adding all the times the speed is increased by 2 meter per second. So let's say if this is 5 seconds. So all I know is that 2, then 2, then 2, then 2, and again a 2. So this means that my speed has increased by a total of 10 meter per second. Okay, so this is the change in velocity of the car. Because I don't know what car the speed was at. Did it start from rest? Was it already moving? I can't tell, right? So it can't be the final velocity or the initial velocity. It can't be the average velocity, because that is the total displacement upon total time. Instead, it is the change in velocity of the car. So congratulations, you're through with the MCQ section of the kinematics chapter, and hope this video was helpful. See you in the next one.